Hello, welcome to Apsana classes. Today in this video, let's know about the half adder, the design of the half adder. So, half adder. We know that half adder is a sequential logic circuit. Okay, sequential logic circuit. Where the design of the sequential logic circuit is having the 6 steps, right? 6 steps that we have already discussed in our previous class. So, see. So, first step is analyzation. So, we have to analyze the design circuit. Okay. Our analyzation is half adder. What is our analyzation? That we are going to design a half adder. Fine. Okay. The step 1 is completed. Next one, determination of. We have to determine how many inputs and outputs that a logic circuit is having. So as it is a half adder, you can add only 2 binary inputs. Only 2 binary inputs. As you are having only 2 binary inputs, you will get the two outputs where that is a sum and carry. One is for sum and one is for carry. So 2 inputs, those are adjacent and addend. Let's say A, B, you can name it. Okay, first one, okay, fine. Let me complete step 2 and then complete step 3. This is a half adder. This is our first step 1, that is analyzation, and then step 2, number of the inputs and outputs. So it as half adder can add only 2 inputs. Okay, fine, 2 inputs, adjacent and addend. So what is an adjacent and addend? It is nothing but, for example, take a milk in a glass. You are adding some more milk in that glass only. That glass itself you are adding some more milk. So the added milk is added. Okay, fine. The milk already present in the glass is adjacent. Okay, I think you are clear with that. Okay, and then as any adder, you can have 2 outputs. One is for input and another is for sum and carry. So sum and carry. Okay, fine. Next one, naming to inputs and outputs. We have to name the input and outputs. So I am naming it as A, B, C for carry, S for sum. Also fine. Then you have to draw the truth table. As we are having the 2 inputs, you get 4 combinations, right? 2 power n, where n is the 2 inputs. So you'll get the 4 combinations. So A, B, and sum and carry. This is our input and this is for our output. Okay. So 2 inputs means 4 combinations. Those combinations are 0, 0, 0, 1, 1, 0 and then 1, 1. Fine. Then you get sum and carry. Carry you will get when if you add 2 numbers, then the number is excess more than 9, then you will get carry, right? The same process it will have in here. So 0 plus 0, of course, will get a 0. In sum, we will get 0. But as we are not having any carry, we put carry as a 0. So 0 plus 1 will get. So sum is 1. As we don't get any carry, we put carry as 0. So 1, 0. The same 1 plus 0 is 1. Sum is 0 and carry. Of course, as we are not having, we assign 0. So 1 plus 1, in a normal in general, 1 plus 1 is equal to 2, that we know. But in binary, it considered 2 as 1, 0, right? Why? As it is following 8421 code. In a 8421 code, we represent 2 as 1, 0. Here, see, 1, 0, 0, 0. So 0, 0, 1, 0. Okay, 1, 0. So sum is 0. If you see 0, so first one is 0 and then in the 10th position we take as a carry. Same process. So sum is 0 but we get carry 1. Okay. So step 4, truth table, relation between the input and output, that we have completed. Now next is simplified Boolean expression of the K-maps. Using K-maps you can get Boolean expression, that was simplified Boolean expression. So you can solve by sum of the products, means min terms, or product of the sums means max terms. Let's go by sum of the products. In the sum of the products, we take ones. Okay, for ones. For sum, I am drawing first. For sum, you take here 1 and here 1. So 1, 2 we have. So for first one, if you see here, first one a is 0. So as it is 0, we take a as a bar. A bar. And then as it is having 1, we take simply 1 as it is associated with 1 itself in sum of product. Okay, sum of product means sum and product, sum of the products. So next one, the next we are having the 1 at this position means 0, 1, 2, second position. So in this second position, third position, if you see here, a is normally 1 as it is associated with 1. So you can take 1, I mean a is normal, but at B you have 0. So 0 representing with bar. So you have to take with B bar. This is for the sum. You get the Boolean expression. If you observe here, it is in deeply, it is same as XOR gate output, right? XOR gate output means A XOR B. XOR B. Simply you can represent. Next one, carry. At carry, we have only one position. That too in our fourth positions. Here in the fourth position, we have A B. You can take directly AB as it is associated with 1. These ones are normally, so as having no zeros, we don't need to take any bars. So carry is equal to AB. So these are the simplified Boolean expressions in a half adder. Fine. Next one we have to do implementation. Means we have to implement using logic gates. So in a logic gates you can draw like simple logic gates also you can draw, or XOR you can draw, or the universal logic gates also you can draw. But as our theme is, we have to simplify the circuit anyway. We don't need to use many logic gates. If you use many logic gates, we will have a number of disadvantages, like the circuit is large and electrical disturbances and all it will create. So we don't need to go for the long circuits. So as we are reducing the circuits, let's also reduce the implementations of the gates here. So simply you can take XOR, right? So XOR, what is the symbol for the XOR? This is the symbol for the XOR. For the XOR inputs we are giving A, B. The output directly it will give A XOR B. Fine. Completed. But here we have carry. In carry, these two are multiplying. As these two are multiplying, we take AND gate, right? AND gate. So what are the input for the AND gates? A, B. Simply you can take from these also. So from these you can take AND gate. So this is for sum and carry A, B. If you really like to draw the sum in a basic logic gates, you can also draw. Let me show you it. Okay. A, B. These two are multiplying here. So you can take AND gate. We have to take AND gate. Okay. AND gate. The inputs are A bar, B. The next one, A, B bar. A, B bar. These two are adding. These two terms are adding, right? You have to give to OR gate. OR gate. So what is the output of this AND? A bar B and A B bar. Then both combinedly adding, you will get A bar B plus A B bar. Simply you can draw this simple circuit too. We can extend using the basic logic gates, or else you can you want to give only A B as inputs. Okay, give, no problem, but you have to implement another gate, that is a NOT gate. Here you gave A, but you want to get A bar. Here also, sorry, here B bar. So here also you have to replace, not replace, you have to introduce another NOT gate here. You gave B to NOT gate, the the NOT gate will give B bar, as it is an inverter, right? NOT gate is an inverter. So this is about the half adder. We have completed the 6th step. Thank you for watching. Please like, share and subscribe.